Today's lesson is on the intermediate value theorem, which we sometimes abbreviate with IVT, intermediate value theorem. So I'm going to give you a definition. It's this, very mathy, proper definition of the IVT. But essentially, I think you're going to find it very much just common sense. Before I give you the full definition, I'm just going to draw a picture. So maybe draw this picture because it will help make sense of the definition. So I have this interval on my x-axis from A to B. And then on my y-axis, I'm going to have f of A, the y value, and f of B, another y value. And then a point in between them, point C, and then a point here. Or really not a point, but I guess just a value here that is x. And the last thing is this function is going to be continuous from these endpoints. Okay, so sketching that, and then I can refer to this as we write the definition. Okay. So intermediate value theorem says if a function is continuous, that is a very important keyword. Unless it is stated that a function is continuous, IVT will not work. So we need to know it's continuous. Okay, so if a function is continuous on the interval from A to B. A comma B. All right, so we're stating that on the interval from A to B, this graph is continuous. Okay, so if it's continuous on the interval and C is a number between f of A and f of B. So those are my y values, f of A, f of B, and I've got C is somewhere in between them. Then there is a value x, in the interval A to B such that f of x equals C. Okay, so that was a big, long, very mathy sentence that basically is stating if you have a continuous function on this interval, then that means that every point between this interval exists. So that means every point in between the interval exists. There is f of x, if x is in between the interval, will have a function value C as long as the graph is continuous. So, that makes sense. If I've got continuity, if I've got a value on the interval, I will have a point that exists on that graph. Okay, so now using the same idea from, intermediate value theorem. This time it says if a function f of x, there's the magic word, continuous, on the interval, so these are x values, A to B, and if my y values, f of A and f of B, have opposite signs, so maybe this y value is positive and this y value is negative, those are y values, then that means there exists at least one value, C, on that interval such that f of C is 0. So I'm going to draw a little picture similar to the last one. So I've got interval from A to B. And then I've got f of A is positive, f of b is negative, and if there is continuity from a to b, then that means there has to be a value on this interval where I have a 0. Okay, so now here we're going to draw out a table. So let's say I have these function values, and I am stating that it is a continuous function. So I have to state that. It's a continuous function, and here are values on this function. So -5, 10. -2, -1. 4, 2, 8, 10, 12, -3. So the question is, what is the minimum number of zeros on that function? So it is continuous. It is continuous on the interval from -5 to 12. Now look at how many times your y value changes signs. So if I go from -10 to -1, that changed signs. There's a 0 there. And now I have negative to a positive, change signs again. There's another 0 there. Well, this is just positive, positive, whoop, and it switched signs. So that means that there is at least 3 zeros on that function. So, and that is because of it being continuous. Okay, so now 3 questions, very easy, pretty obvious, but the idea is they're obvious because of the intermediate value theorem. So one night, the outside temperature at midnight, so at 12 a.m., was 42 degrees. 42 degrees. At 10 a.m., the next morning, the temperature was 57 degrees. Well, let's think about that as a function. We have time. Time is continuous. Also, temperature is continuous. You can't jump from 30 degrees to 50 degrees without passing every temperature in between. So, must there have been a time in between midnight and 10 a.m. when the temperature was 50? So, is 50 in between 42 and 57? Yes, there has to be a time. Okay, must there have been a time in between those two, midnight and 10 a.m., that it was 40? No, there doesn't have to be one based on the intermediate value theorem. Then it says, could there have been? Well, yeah, there could have been. All we know, we only know the endpoints. We know these two endpoints, 42, 57. It could have gone up, it could have gone back down and then back up. So that could have happened, but we don't know that based on the information given to us. So there is your video on the intermediate value theorem. Good luck with your lesson.